Hey class, I got asked about homework 7 and how to do it. If you look at the PowerPoint, the lab PowerPoint for homework 7 that's in the module, you should see basically how to do it, but let me give you a bit of a rundown. I'm not going to solve the whole thing for you, but I'm going to show you sort of my process of thinking about these things. The first thing that I think about is I go in here and look at the data. I have on my other screen over here, I have my the homework sheet up that tells me what each one of these things is. So we have campaign ID, a unique identifier for each one of our units here. That is not important to me. That's not going to be predictive, so I don't much care. But it is important to have it in because this is a database-like situation. I'm not going to delete it, but I'm going to think about deleting it. The sender of the email, we have different email senders. Here, if we scan through all of our data, we see that most senders are 3, but we also have 10 in here. Subject len is number of characters in the subject. Body len is, let me do this so you can actually see. Subject len is number of characters in the subject. Body len is number of characters in the email body. Mean paragraph len is the average number of characters in the paragraph of an email. The day of the week is which day it was sent on. If it is a weekend, it is flagged with a 1. If it's not a weekend, it's flagged with a 0. Time of day, we're going to actually convert this to a numerical format. I'll show you how to do that in a second. Category is category of the product the email is related to. Product is if the product is an email is related. Mean CTA len is average number of characters in a CTA, called action. Is personalized is a Boolean. That's number. Where's that one? That's the number of CTA. Called actions. Mean CTA is the mean there. What do we have here? Is image is if there's an image in there. Is personalized if it is personalized. Is quote is number of quotes in the email. Is timer if there's a Boolean flag if the email contains a timer or not. Uses emoticons. Contains a discount code. Contains a price. Contains an urgency. In there. There is some screwy stuff right here, like that right there, where it says 5,499, 5,499, 500,499. This should be a Boolean flag, so there should be 1 or 0, but you know what? It's not a problem, it's not our data. But if we were creating this data, then we would probably want to check that out. Though it's not going to matter too much. The number is not meaningful. It is. It's only it's not necessarily meaningful. It's only that there are different ones in there. So the first thing I'm going to do is I'm going to create a. I'm going to copy this right here, just so we know what we're talking about. I'm going to create a numerical value for noon, morning, evening, because I want to replace this because this is not usable in our regression. So to do that, I'm going to use what's called an IFS. So that's equals IFS, and then we're going to do a logical if test. Basically, if that equals morning, I'll show you what this looks like in the end. If that equals morning, we're going to say 1. If that equals noon, we're going to say 2, and if that equals evening, we're going to say 3. Easy as that. I just come down here to the bottom, I fill down, that fills it all out, and then what I do is I'm just going to copy that, and I'm going to paste those values in. That replaces all of those, and I can just delete that. So now my time of day is of morning, evening, morning, noon, or evening is now 1, 2, 3. Simple as that. If you want that, again, just rewind the video and check out the function I used. All right, so let's actually run an individual regression. So we're going to pick something out of here. I'm going to say our dependent variable over here is click rate, right? And I'm going to look over here and I'm going to pick something that I think may predict click rate. So what I'm going to do is I'm going to go over here to data, and I'm going to choose data analysis. And under data analysis, I hit regression. All right, my input Y range is going to be here. I'm going to select all of that right there. That gives me my input Y range. Y being the output variable, or the dependent variable, or the predicted variable. My X range, I think it's going to be the subject line. I'm going to choose that for right now. I can change my mind later. There are labels here. I don't want this in a new worksheet. I want this just over here, probably in like X. So I'll say X1. I'll say X2. Now I'll say X1. Doesn't much matter. I'm not going to choose anything else for this. I'm just going to go ahead and use this. So we have our independent variable of subject length and our dependent variable of click rate. Click OK. And that gives us some information. Come over here. I'm just going to expand this so that we can see it a little better. And there's a few things I want to look at. One of those things, I'm going to look at the R square. That is going to tell me how much of the variation is being described by this model that I've created. In this case, it's about 3%, because this is a percentage, so our R square is telling us that it's about 3%, which is not bad. Our significant F, if we come over here and change that into a number, our significant F is good. It's below 0.05. Our p-value is also below 0.05, so that's pretty good. But let's take a look at the actual change here. So our subject length, what this means, I'm going to write out the regression equation here so you can see it. So our regression equation for this very simple regression that we've just done is y, or in this case, we'll do it on here. Call it click rate equals, I'm going to truncate this a little bit. I'm going to say equals 0.085 minus 0.0005 times, what is it? Subject len. So that's our regression equation right there for this very simple one. What this is basically saying is that for each character increase in subject length, the click rate decreases by 0.0005. It explains a small part of the variation in click rate, but not a lot. But it's pretty good in explaining it. It gives us some information. Let's try something a little different. Let's do the same thing, but let's do it with body instead. So I'm going to go over to data, analysis, regression. Everything's the same, except I'm really just going to go in here and change my C's to D's. I can also just highlight the information there. Click OK. All right. In this case, our R square is 0.06, so we get a little bit more prediction, so it's about 6% of prediction. Let's take a look at this. I'm actually just going to go ahead and highlight everything I actually want to read. Convert that into a number. We're going to increase that to, say, 4. So in this case, our regression equation for body length, we have significance here, that's good. Some predictive power of 6%. But in this case, our regression equation would be click rate equals 0.0823. Oh man, is that negative or positive? It is negative. Okay, there we go. 0.03 minus 0.12345. I think that's it. 6 times body length. So there's our regression equation for that. So not very. It predicts about 6%, which is interesting, but it for each character that increases, it lowers the click-through rate by a very, very tiny amount. Let's combine the two and see what we get. So in this case, what we're going to do is I'm going to do the exact same thing. Not insert, it's data. Data analysis, regression. So in this case, I'm just going to take, show you what that looks like. we're just going to take basically all of the C and D together. You have to use, when you're using multiple regression, multiple variables for your regression, you have to use them that are adjacent to one another. So, like, we can use these two. I may pull in paragraph length before we're done with this explanation. I'll let y'all just go ahead and do it on your own. But let's see what 2 look like. Those 2 specifically. Yep, I want to overwrite it. All right, so I'm going to do the same thing here. Put them numbers. Okay. So F statistic very low, P very low, intercept, and R square. R square is not a lot higher than it was when we just were using body length. It's now only a tiny bit higher with including subject length. So our regression equation in this case is click rate equals 0.0, we'll call it 97. We'll say 979. That rounds up nicely. Minus 0.0003 times subject length minus 0.123452 times body length. That's our regression equation there. Okay. So in this we get some predictive power. We have a new regression equation. Let's pick 3 things, but let's pick 3 totally different things. In this case, let's pick day of the week, is weekend, and time of day. That's the 3 we're going to choose. And then I'll let you go off on your own and pick this. Actually, let me show you kind of the expectation of what I want to see in your report, and then I'll send you off anyway. Okay, so for this, I'm going to pick day of the week, is weekend, time of day. I'm going to scan all the way down to the bottom here. All right. Output range is the same. They do have labels. Go ahead and hit OK. Yep. And let's take a look at what that looks like. All right. All right. Let's see. We are a significant F, but one of our variables here is not significant. Day of week is not significant. Is weekend is significant, but it's less significant than anything we've tried thus far. Time of day is significant as well. So when we see this lack of significance, probably want to just go ahead and start again and throw it out without moving forward. But let's take a look at it. If we were to write a regression equation, we could say it's click rate equals 0.09 plus 0.00023 times day of week plus 0.01502 times is weekend minus 0.01968 times time of day. So in that case, we don't have significance here, so I'm hesitant to even move forward with this thought, but that's what our regression equation would be. And to explain that a little bit more, what that means is for if for different days of the week, we get, well, we don't have significance, so we don't get anything from that one. If it's the weekend, basically we get an increase of 0.01502 to the click-through rate. So if an email arrives on the weekend, we get a small boost. And depending on the time of day, it appears that in increasing time of day, we get a small reduction. So as it goes from 1 to 3. We can also do it 0 to 3 as well for multiple things. All right, so let's take a look at how we're going to write this. Let's just go ahead and look at the assignment itself. Question part A is select one variable that you believe to have an impact on the click-through rate, run a regression model using Excel using independent variable X, and then click on click rate as the dependent variable, run a regression model in Excel, look at your statistical output, and answer the following questions. What is your regression equation? Well, we've already talked about the regression equation. You know how to write that now. How does your dependent variable change when your independent variable increases by 1 unit? Remember, that's what the regression equation is telling you. Are the p-values of your intercept and variable coefficiently statistically significant? We just took a look at those p-values where they are. And what is the r-squared for this model? Remember that r-square is up here, and that's a percentage that tells us how predictive it is of the variability. Okay. For part B, 30 points. Select one more additional independent variable of your choice and run a simple multi-regression model in Excel. What is your regression equation? We've already written a multi-regression equation. What is your dependent variable change when each of your independent variables increases by 1 unit? Are p-values for your intercept variables coefficiently statistically significant? What is the r-squared? Is your overall model statistically significant? So yeah, there you go. That's basically what I'm looking for. I'm looking for you to answer those questions. Make sure to take a screenshot of this for part A and a screenshot of this for part B. Let's say, for instance, though, that you want to use mean paragraph length and subject length, and you don't want to use body length. Like you don't think body length is predictive enough, or let's say you don't want to use subject length. Actually, let's do that. It doesn't much matter that it doesn't make sense. Let's say I don't want to use that. I want to use this one and this one. They need to be together. And so you could do that a couple different ways. You could insert this and just cut that and paste it there. Then just delete this right there. Just move them around like that. And then you can just pick these. So that's one way to do it. You can also just delete entire columns if you don't think you're going to use it. Like day of week is not significant. I know it's not significant, so I'm just going to delete that column out of there. Just make sure that in the end you may want to just copy this entire tab over to a new tab so that you have your basic data. It doesn't much matter to me. But yeah, give me your output and everything. Let's run that one more time. Let's actually run subject length and mean paragraph length for that too, just so that you know for certain what we're talking about. We're going to do subject length. And this is no longer V, it's U, because I deleted a column. And the output range, I also deleted a column there, so it's going to be W. Click OK. All right, let's see what we get. We get about 5%, and here is that. Let's take a look. We've got a significant F. It looks like we've got significant p-values. We definitely do. And then remember, if I'm writing my regression equation equals 0.0, let's call it 621. Yeah, 4 is enough. Minus 0.004 times subject length plus 0.004. Kind of cancel each other out. 0.004. Yeah, there's 3 zeros in there. Times mean paragraph length, and let me come back and fix that too. There we go. So there's my regression equation for this. What that means as my subject length increases by 1, my click-through rate decreases by 0.0004. As my mean paragraph length increases by 1, my click-through rate increases by 0.0004. That's what that means. That's how you answer those questions. I hope that helps.